Hey everybody, it's Miss Famer. This is your video on everything that's really important from our Unit 1 this year. So, first thing I want to talk about before we get into that is just different number types. We talked about all different number systems. We talked about real numbers, irrational numbers, all sorts of numbers. So the first number that's really important are real numbers. A definition for real numbers is all numbers that exist. So literally any number you can think of, whether it be a decimal, not a decimal, a fraction, a whole number, negative number, is a real number. And if you look in the example, pi is even a real number. And it says, how will I remember? Well, to remember, just think of it's every single number you know, a real number. It's any number. Other important definitions are irrational numbers. Definition is that real numbers that cannot be written as a fraction. When I think irrational, I think it means like crazy. It means that like it doesn't make sense. So it's any number like a crazy repeating decimal. If you took either of these radicals and put them in the calculator, they would give you like crazy repeating decimal. So anything that's like never ending, always doesn't have a pattern, pi, that's completely irrational because that's like a crazy decimal that never stops. So we call those irrational numbers. Rational numbers then, it's kind of like the opposite. Rational numbers are lots of numbers, and they're basically everything besides the irrational numbers. So you can have decimals, you can have fractions, that's totally fine, but they just can't be like the crazy non-ending, non-repeating, all of that stuff. So it's basically everything else. A hint here is also simplify. Sometimes you'll get like a crazy, you'll get a fraction, you're not sure about it. If you put it in your calculator and it simplifies to something that's ending or it has a nice pattern, then you can say it's rational. Integers, this one's a little bit more common. Integers are nice because you can think of it as really any number on the number line. It's positive or negative numbers, whole numbers, and zero. So like even picture these numbers here. If they were along a number line, think about like when you were a little kid and at your desk on like elementary school you might have a number line. Any of those numbers are good. Negatives, positives, or zero. Those are integers. Then you have whole numbers. This one's a little more obvious. They're any whole number and it actually includes zero. So that's just a common mistake. Whole numbers include zero. Natural numbers. Natural numbers are counting numbers. That's how I remember them. Think about naturally, how do you start counting? Well, you start with the number 1. If you ask a little kid, okay, start counting, they don't say 0. They say 1, 2, 3, 4. So your natural numbers are just what you would naturally say when you're counting. So here are your relationships of numbers. It's good to know how all of these numbers are related. So at the very top bubble, I always call these my real numbers because every other number system falls under real numbers. So once you know that a number is real, you can break it down into 2 groups. It's either irrational, crazy repeating decimals, or it's rational. So it could be a decimal or a fraction, but it ends, it's terminating, has a nice repeating pattern. Okay, once you know it's irrational, you're done. But if it's rational, you can continue to break it down. If it's a rational number, it might be an integer. Remember, positive or negative whole numbers, including 0. If it's an integer, it might be a whole number. So now we're just talking positive whole numbers and 0. And even more specifically comes your natural numbers. That's what you would naturally say when you're counting, like 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, sometimes you'll get charts like this where you have to pick a number and then check off all the different values. You got these in some of your packet work that we've been doing. So let's just do a couple. So let's look at, 3/4, for example. 3/4, is that a natural number? No, because it is not a number you would use when you're just naturally counting. Is it a whole number? Definitely not, because it's a fraction. Is it an integer? Is it a number you'd see on your number line, negative or positive or 0? No. Is it rational? So I always look at rational and irrational, and I kind of debate. Rational or irrational, which one is it? Well, it's rational. It's not like a crazy repeating decimal or fraction. In fact, 3/4 is the same as 0.75. That's not a crazy repeating decimal. That's totally fine. Is it irrational? No, it can't be both rational and irrational. It's always one or the other. And it's real, because remember, any number we can think of is a real number. If you want, you could always pause here, and you could decide if you didn't try to do the rest of the chart. That would be totally fine. All right, number systems also have symbols. So you want to know at least some of the most common symbols, such as the symbol for real numbers is kind of like this bolded R. The symbol for rational numbers is kind of weird, actually. It's a Q. Irrational is like a Q prime. Integers is actually Z. Whole numbers, you don't see it as common. Sometimes they just call it like W. I wouldn't worry about that one as much. And natural numbers then is like this bolded N. So you should just be able to recognize the symbols. So if you ever come across them in a question, you're able to use them. Not sure what that notation is down there. Okay, the next part of this unit after numbers was sets. So we have to be able to work with sets in all different ways. Sets is really just a collection of numbers. A lot of times we see sets written in curly brackets. And something important you need to know about sets is that the elements in a set do not repeat. So you'll never see like 2 4s in a set. If a number is in a set, you only see it once. You should also be feeling comfortable working in roster notation, interval notation, and set builder notation. So roster notation, the best way to think about roster notation is just like a list. I think about like the roster of a baseball team. It's just a list of the players' names. Here's an example. The set of numbers from 2 to 6 inclusive. Remember, inclusive means including. Sounds just like it. So I want to list the numbers from 2 to 6, including 2 and 6. 2, 3, 4, 5, 6. That's how it looks. Interval notation. Interval notation is when you use the parentheses and the brackets. So remember, parentheses is when you're not including the number. Bracket is when you want to include the number. So this one says the set of numbers from -2 up to and including -3. So it says from -2. So I'm not including -2. So I'm going to put a parenthesis on the -2. Now in interval notation, we don't list out all the numbers. We just put like the starting one and the ending one. Now it says up to and including keyword 3. So now I'm going to put the 3, and the 3 will get a bracket. That is our interval notation. Sometimes you want to relate your interval notation on the number line as well. So this is showing us on the number line that 14 is included, and it's going up to 19, which is not included. So it's important to know that when you're not including something on a number line, it's an open circle. So like an open circle and a parentheses mean sort of the same thing, just in a different situation. And a bracket is what we would use for a closed circle, or like a circle that's colored in. Sets with inequalities. We've seen a bunch of these too. You want to make sure you know what inequality symbol matches up. It says which of the following inequalities represents the set of numbers in the roster below. So in this roster, it's 7, 8, 9, and 10. So I want to know which choice also says include the numbers 7, 8, 9, and 10. Now I'm looking here. This inequality symbol doesn't have an equal sign under it, so that's not saying to include 7. So I know A can't be a choice. If I'm looking here, this says include 7, because remember, if there's an equal sign under it, it means to include it. If there's not, it means do not include it. So choice B is including 7, so that's good. Is it including 10? Yeah, and so is my roster notation. So it looks like B is probably going to be my answer, but let's just check. Yeah, look here. C doesn't include 7. D says X is greater than or equal to 7. So it does include 7. And it would be, so think about numbers greater than or equal to 7. 7, 8, 9, 10. But it wouldn't stop there, right? It could go 11, 12. We could go on and on forever. So that's not what we're looking for either. So choice B was our final answer. All right, set builder notation. This one's a little weird because it looks crazy, but it's just about making sure you're focusing on the right part. What this is actually saying is X such that -4 is less than or equal to X is less than or equal to 2, where X is an element of, and remember, Z means integers. So what this is telling me, and what the part I want you guys to focus on, is this part here. It's saying it's any numbers between -4 and 2, including -4 and 2, that are from the integer. So let's list this out. What numbers would these be in roster notation? Well, it would be -4, let's see, -3, -2, -1, 0, 1, up to and including 2. They're all integers. They're positive or negative whole numbers and 0. If I wanted to write this in my interval notation, I would include -4 and I would include 2. We could even go one step further and do this in, let's see, on the number line. We want to put -4. We want to put 2. It's included, so they'd both get closed circles. And it'd be anywhere in between. So these are all saying the same thing, just in different ways. All right, so I think at this point it's just going to be nice to do a quick summary of like what symbols mean included and what mean do not include. So I think most commonly we know that bracket means including, parentheses means not including. We also talked about how then closed circle on the number line is when we include, open circle is when it's not including. And then if you have a less than or equal to or a greater than or equal to, the key is the equal to. That means include. If you just have a less than or a greater than, it means do not include. So sometimes that's helpful just to kind of break it down. Okay, the next part of the set stuff was when we did like the union, intersection, complement, and I know we did a quick review on this, so I won't spend forever talking about it. The complement means what's not in the set. And sometimes, like in your worksheets, it said like A prime. That means a complement. They want to know what is not in A. So let's do a quick example. It says, example 1, there's your universal set, and then you have a subset A. And they want the complement of set A. Now, complement means they want everything that's up here that's not in set A. A good trick for this one, complement a lot of times when it's set up like this means cross off or cross out, complement cross out, remember? So anything in set A you can cross off up top. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So whatever's left is your answer to the problem. So it's 1, 2, and 12. So it's whatever wasn't in set A. Intersection. Intersection we like to think of as the overlap. What do the sets share? What do the sets have in common? So here we have a universal set. We have set A, we have set B, and they want to know A intersect B. Remember, that's the symbol for intersection. So what do A and B have in common? Well, I see they both have a -7. And is that it? I guess so. So the intersection of these sets is just -7. It's fine for a set just to be one number. And then union is everything in both sets. So if we look at our example, we have our universal set, our set A, our set B, and they want us to find A union B. That U stands for union. So they want everything in set A, everything in set B. Just be careful not to ever repeat. So it would be A, L, G, and B. No repeats, so nothing to worry about there. All right, a lot of times you get big questions like this where it'll ask you for a whole bunch of different things. I think it'd be worthwhile actually to do this one together. Let's just do this bottom one. So they give us a picture. They ask for a list, and this is actually from an IB textbook, so this is an IB question. They ask for the elements in set A. Set A is everything in circle A. So B and D definitely, but B and D aren't the only things in circle A. Look at the whole circle. It's B, D, E, and H. So following that same thing, everything in circle B then includes the E and H in the middle, and then it's F, I, and J. A complement, everything that's not in circle A. So everything that's not B, D, E, or H. So I'm literally going to list everything else. Be F, I, J, even the stuff on the outside. It's not an A. A, C, K, G. Sorry, I'm like all diagonal here. This then says A intersect B. Where do they overlap? They overlap at E and H, right in the middle. And A union B, that's everything in A and everything in B. So it's B, D, E, H, F, I, and J. All right, I think the last thing I want to talk about, let me just make sure, is scientific notation. So just a few more here. Scientific notation. What is scientific notation? Scientific notation is basically just a way to write really big or really small numbers. The key here is that it consists of two important parts. The two parts that it consists of are a number between 1 and 10, and then the second part is always just times 10 to the some exponent. Here's a couple of examples and non-examples. This first one here is a good example of scientific notation. There's a number between 1 and 10 times 10 to raised to an exponent. This here is a bad example. Do you know why? Hopefully you're thinking because this first number isn't a number between 1 and 10. So this is not scientific notation. So a couple of examples. You should be able to convert things into and out of scientific notation. If you're converting into scientific notation, you have to make a number between 1 and 10. So right now the decimal point's at the end of the number. I want to move it 1, 2, 3, 4, 5, 6 places so that I create a number between 1 and 10. Since I moved it 6 places, my exponent on my 10 becomes 6. If I'm moving in the other direction, so let's see, I'd move this 1, 2, 3, 4 places to make a number between 1 and 10. But since I moved to the right, or another giveaway is that since it's such a small number, I have to use a negative exponent. So a good way to remember this is if you start with a big number, positive exponent. If you have a small number, negative exponent. Now, you can also convert numbers from scientific notation into standard form. So if you're given a number, you might want to move it out of scientific notation. So right now I have 1.015. I know it's a negative number, so this is going to end up being a really small number. So I know I'm going to have to move to the left 8 places. 2, 3, 4, 5, 6, 7, 8. So now my decimal point's over here. And I fill all those loops with a 0. So 1, 2, 3, 4, 5, 6, 7. I'm going to need 7 zeros. And then you just write everything that came after it. So this is what it was before it was in scientific notation. I can do the same thing in the other direction. 5.024 times 10 to the third. I move 1, 2, 3 to the right. I know I'm going to the right because since it's a positive exponent, I'm going to end up with a big number when I'm done. Okay, almost done. A couple of quick things. I want to just talk about multiplying and dividing in scientific notation. So when you multiply in scientific notation, you simply multiply these numbers out front, and then we add the exponents. So you'd multiply 5.1 times 2.5, and let me do that on the calculator here. Just make sure I don't make any silly mistakes. 5.1 times 2.5 is 12.75. So I get, let's see, 12.75. I keep the times 10 to the, and then I add the exponents. 4 plus 3 is 7. Now it says, is the answer in proper scientific notation? Why or why not? Hopefully you're noticing that that first number is not in proper scientific notation. It's not between 1 and 10. So let's make it between 1 and 10. Let's slide that decimal place one more spot. So now I have 1.275 times 10. Since I moved it one more space, I have to bump up my exponent one more. So it's 1.275 times 10 to the 8th. Division works really similarly. When we divide here, we do 6.2 divided by 3.1, which I know is 2, times 10 to the. When we're dividing, we subtract our exponents. 6 minus 3 is 3. Check that out. Is that in proper scientific notation? Sure. It's a number between 1 and 10 times 10 to the something. So this is my final answer. All right, so that's it for Unit 1. Those were all the big ideas. If there's anything that you want to come back to at any point, make sure you do. Hopefully you have found this video helpful, and hopefully it'll help you tomorrow in class when you work on the Unit 1 packet. Talk to you guys later.